2009 higher level question 8, photoelectric effect. So the first thing we're going to do is mark our questions. So we have A, what is a photon? And then B is on this investigation to establish the relationship between the current flowing in a photocell and the frequency of light incident on it. So B, we have to draw the label diagram. C, we have to use the graph. D, what is the maximum speed? E, explain why a current does not flow. And then F, we have to draw a sketch of the graph. And then G, what's the conclusion? So by marking out each of the questions in the given question 8, we can then tick them off as we've done them and making sure we don't miss a question. Otherwise, it's too easy to miss a question here. So the first one here we have is, what is a photon? So we say A. So a photon is described and was described by Einstein as a bundle of light energy. So we can say it's a bundle of light energy, or a packet of energy, or a bundle of electromagnetic radiation. So any description like that would do for a photon. And again, we were getting 3 for saying a packet or a bundle or a quantum, and 3 for saying that it's electromagnetic radiation of some sort, whether it be it light energy. So B then was the investigation. So B says to draw a label diagram with the structure of the photocell. So here we would need to label our anode, our photocathode, which tends to be cylindrical for focusing the electrons. We would have to have an evacuated tube, and we would also have to have our glass casing, and we should be labeling each of those. So there was 12 marks going for that. So basically 3, 3, 3 and 3. So we'd have 3 times 4 marks. And if we forget to label it, then we would lose a -1. And that's for each missing label. So any diagram you're drawing, whether it be it for an experiment, demonstration, or something like this where we're drawing the photocell, we have to make sure that it is a fully labelled diagram. So C then says, using the graph, calculate the work function of the metal. So our work function is given by HF, where F is our threshold frequency. And we can see from the graph that the threshold frequency is that point of intersection of the line with the x-axis. So in other words, our threshold frequency is 5.2 by 10 to the power of 14 hertz. And then H is Planck's constant. And we can see down the bottom of the question that Planck's constant is given to us, so we don't need to go to our tables. But if we weren't given Planck's constant, we could go to page 47 in our tables, and we would see our Planck's constant here, the third one down. Okay, so if it's not given to you, you have to be able to know where it is in your maths tables. So page 46 and 47 is our constants. So we have 6.6 by 10 to the power of -34 joules second for Planck's constant. And therefore, by summing into our formula, we have our work function is 6.6 by 10 to the power of -34 multiplied by 5.2 by 10 to the power of 14. And that gives us a value for our work function of 3.432 by 10 to the power of -19 joules. So we have 6 marks going for that. So 3 for our formula and substitution, and 3 for our answer. And of course, if we don't have any units, it would be -1 for units. So if it's incorrect units or no units, -1. Okay, so D then says, well, what is the maximum speed emitted by the electron when light of wavelength 550 nanometers is incident on the photocell? So the fact that we're given our wavelength means that when we're looking for the energy of the photon, rather than using E is equal to H times F, we're going to have to manipulate it to include the wavelength. So we know from, so that's D. So we know from Einstein's photoelectric law that we have the energy of the photon is given to the electron, and the work function is the energy that is gained by the electron so that it just breaks free, and any extra energy gained by the electron is used for kinetic energy. But we know that C is equal to F times lambda, and therefore if we're given our wavelength, then I need to replace my frequency, which I don't know, in terms of C and lambda. And now if I go back to my question here, you can see I'm also given the speed of light, which is C. So if I sub in my values for F, my formula then becomes, instead of HF, it becomes HC over lambda is equal to phi plus a half mv squared. So we know what H is. It's our Planck's constant. It's given to us there as 6.6 by 10 to the minus 34. We're given C, the speed of light. So we can see that that's 3 by 10 to the power of 8. We're given the wavelength in the question. That's 550 nanometers. But of course I can't put 550 nanometers into my question. So instead I say, well, that's 550 and nano is 10 to the minus 9. Phi, well, we've worked out phi, our work function. We said that that was 3.432 by 10 to the minus 19. And that's joules. And then we have the mass and the electron, right? So the mass and the electron is given to us as 9.1 by 10 to the minus 31. But if we weren't given that, again, we can go here to page 46 in our maths tables and we can see the electron mass is given to us with all our constants. So now all I have to do is manipulate my equation to get V on its own. So you can do that first and then sub in the values, or you can sub in your values and then rearrange. It's up to you. It doesn't make a difference. I tend to prefer to rearrange first. So I have a half mv squared is equal to hc phi minus the work function. And then I'll multiply across by 2. And then I can divide across by m and get the square root. So now if I sub in my values, I have 2 times Planck's constant times the speed of light over the wavelength. And then that is minus the work function divided by the mass and the electron. And then we will get the square root of all of that. So we put that into our calculators, making sure that you're definitely using your fraction button and your brackets button, and making sure you're using your exponential button properly. If not, work out each stage separately. So work out your half mv squared, work out your hc phi, and work out your work function, and then get V on its own, making sure not to round too much until the end. But if you rearrange it and get it all in one go, you end up with 1.922 by 10 to the power of 5, and that's meters per second. And again, if we don't have the correct unit, we will lose a mark. So we had 3 for setting up our equation, 3 for our correct substitution, and then 3 for our answer, and of course -1 if incorrect unit. Okay, so E then says explain why a current does not flow. So again, always underlining the keywords in your question. So why does it not flow when the frequency of light is less than 5.2 by 10 to the power of 14? So that is E. So basically, if the frequency is less than the threshold frequency, no photoelectric effect will happen. And if the photoelectric effect doesn't happen, that means there is no electrons being released from the surface of the photocathode, and therefore no current will flow. So we were getting 3 marks for saying if the frequency is less than, and then the threshold frequency was another 3 marks. So really we were getting 3 followed by 3 here. So frequency less than was 3 marks, and threshold frequency was another 3 marks. Okay, so F then. Well, F says the relationship between the current flowing in a photocell and the intensity of the light incident on the photocell was then investigated. So we have the current versus the light intensity. Readings were taken and a graph was drawn to show the relationship. And we have to draw a sketch of the graph drawn and how was the intensity of the light varied. So this is the investigation you did using your PhET simulation. And the graph that you sketched was light intensity not light intensity, current, and it was against light intensity. So your light intensity was basically 1 over d squared, which then gave us a directly proportional relationship. So in other words, the current is directly proportional to the light intensity. So the more intense the light, the more photons there are. The more photons there are, the more electrons that are released from the surface of the metal. So for every 1 photon, 1 electron is released. And therefore, if there are more photons, the light is more intense, then more electrons are released, and therefore there is a greater current. But of course, the closer the lamp is to the photocell, the more intense the light is. And therefore, we would say the light intensity is inversely proportional to the distance squared. So if we don't square the distance, we'd get a curved graph instead of a straight line graph. So how do we vary the light intensity? Well, we vary the distance of the light source. In other words, the closer the light to the photocell, the greater the light intensity. Hence, the greater the current. So we had 5 for explaining how we varied the light source. And we had 3 for the correct shape of our graph. So 3 for our graph and 3 for labelling our axes. So again, any diagram has to have labels. So even if it's a graph, we're going to lose marks if we're not labelling our graph. Okay, so G then is what conclusion about the nature of light can then be drawn from these investigations? So our conclusion is that light is made up of photons. Because for every one photon that strikes the surface of the metal, we have one electron being released. Sorry, not 5 marks, it was 6 marks. Okay, so it's this whole battle between the wave-particle duality of light. So this experiment was demonstrating the particle nature of light.